All right, for 2-4A, the first thing is to approximate the mean of the group of data. So I'm not going to do this all, but you would need your midpoints. Okay, and so like the middle of that first class is 61, because in between 60 and then it's 64, 7. That last one doesn't make any sense, but I think it's 68. Oh no, 70. Okay. And then you would multiply your frequencies times your midpoints, add them all up, and then divide by the total of your frequencies. So you would also have to add up all your frequencies and then add up all of your x times f's and then divide them, okay? We are doing measures of variation today. This is super important in these terms and these symbols, and the method is going to continue to come up. So we have to make sure that we really understand what we're talking about. So measures of variation, we're just continuing with that, but we are now trying to figure out how spread out your data is. Okay, so we talked about how to find the middle of your data, like the mean, the median, the mode, the central tendencies. Now we need to understand how spread out it is. There are two main ways to do it. One of them is range, which is simple, and we know how to do that. It's just not quite as useful, but we can do range. The second one is standard deviation. So we're going to figure out how to calculate standard deviation today and kind of talk about what it means. Range is just your maximum minus your minimum. That's it. Take the biggest, subtract the smallest, and then know how many numbers fall into your grouping of data. So we have two different corporations, okay, with their salaries, and we want to know which corporation has the greatest range, okay? So you just look at the first one and you look for the maximum and the minimum. So it looks like the maximum is 47 and the minimum is 37. Okay, so you don't start off very low. 37 is pretty high, but you also don't top out very high. So like if by the end of your career you're only making $10,000 more than you were at the beginning, that might not be great. So the range is just going to be 47 minus 37, which is 10. So the people at the bottom and the people at the top only vary by $10,000 a year. So corporation B, your lowest is 23, which is super low, and your highest is 58, which is a lot better. So that range, I know my handwriting's super sloppy, sorry. 58 minus 23, which is 35. So the same number of values, they each have 10 numbers. And corporation A starts you out higher, so you get to start at 37. But their range is only 10, so you don't really have a lot of room for growth there. Whereas corporation B starts you out really low, but you could end on the higher end at 58. So that range is 35. Okay, so range is just how spread out your data is. The people in corporation A make a lot closer to each other than people in B. All right, and deviation helps us find standard deviation, which is super important. So a deviation just deviates, right? How much does something deviate or move away from the average? So the difference between your data point and the mean or the mu of your data is your deviation. So you have to take every data point and subtract the mean to be like, how far away is this from average? How far away is this one from average? You want to know, and you want to know whether it's above average or below average, okay? So you have to subtract in that specific order. So your deviations are x minus mu. So you find the mean and then subtract the mean from every data entry to find its deviation, x minus mu, okay? So it's individual deviation, and then we're going to find standard deviation, which is for the group as a whole. So my corporation A, I put all of my salaries in this chart, okay? So these are all of the numbers that we had. I found the average for them. Okay, I didn't make you do this, but you know how to find the average. Add them all up and divide by however many you have. We got 41.5. Okay, so I think you add them up, you get 415, and then there are 10 numbers. So 415 divided by 10 gave us mean. That's our mu. To find your deviation, you take every data point and subtract the mean. So like 41 minus 41.5, 38 minus 41.5, all the way down to figure out how far away each of these is from average. How far away are you from the norm? If you look at the first one, 41 minus 41.5 is super close, but it's below average by a little bit. So that deviation is going to be a negative 0.5 because you are below average, okay? By the time you get down to 45 and you're subtracting 41.5, now you're above average, so your data point is going to be, or your deviation is going to be positive, okay? So I'm just going to paste these so that we don't have to do them all. But any of them that are negative are below average. Any of them that are positive are above average. So you're below average for the first three, and then 41.5 minus, or 45 minus 41.5 is 3.5. So you're 3.5 more than your average, okay? The most you're going to get above average in this place is positive 5.5, which is our maximum, okay? So the maximum and the minimum are obviously the furthest away from the average. But those are your deviations. That's how far each data point specifically moves away from the average. Now, to find the standard deviation, you have to build on this. So you find your deviations and then you continue. We have to find our variance before we can find our standard deviation, okay? So the variance is you add up, that's what this means, right? You add up all of your deviations. X minus mu's are your deviations, but you're going to square them to make them all positive, okay? So if we added up all of our individual deviations right now, we would get 0 because you've got some positive and some negative, some above average, some below average. So we're not able to add them all up right now because it doesn't give us a tangible number that's going to be able to be divided. So to help us be able to use it, we're going to square them because when you square something, you make them all positive. So we're going to square all of our deviations, and then you divide by however many numbers you have, okay? When you do that, you get your variance. This little O with the tail at the top, okay, this is lowercase sigma. We've talked about capital sigma, okay? Like this is capital sigma. That's the lowercase sigma. Because lowercase sigma is kind of a mouthful and it's hard to get to, I just say baby sigma. But that's me. Don't go to college and call things baby sigma. So baby sigma squared is your variance, okay? We want to know, those are because your numbers are being squared. You have to square your deviations in order to be able to use them properly. Get your variance. Variance isn't super helpful because we squared everything, so all my numbers are bigger. So to get the standard deviation, I just take the square root of my variance. This is the important one. Standard deviation is the square root of your variance. So you're going to square root baby sigma squared and get baby sigma. So just baby sigma by itself is standard deviation. You find it by getting, so you find your deviations, x minus mu's. You square them all. Then you add them all together. And then you divide by however many you have. And then you take the square root. So you just start on the inside and work your way out. But that's standard deviation. Okay? So next to each of these steps, I want to put the symbols so that we can kind of build our formula as we go. So you find the mean of your population. You need your mean. Mean is mu. Okay? Find the deviation of each entry. That's your x minus mu. So you take every data point and subtract your mean. Square each deviation. So that gives you your x minus mu's squared. Add them to get the sum of squares. So add sum sigma, all the x minus mu's squared. So it looks awful, but if you look at it piece by piece, you're just building. You find the average, you subtract each one with the average. Then you square all those numbers, then you add them all up, like it's just building. Divide by n to get your variance. So variance is baby sigma squared. And you get them by adding up all of your x minus mu's squared divided by n. Then you take the square root to get your standard deviation. Standard deviation is just normal baby sigma. So, all your x minus mu's squared added up, divided by n, and then take the square root to get baby sigma by itself. So piece by piece, not too bad. Looking at it all at once looks overwhelming. Okay, so here's our corporation A. We did all of this already. We had our salaries, we found our mu. Mu was 41.5. So we took each of those and subtracted them to get our deviations. Now, I'm teaching you how to do this, so we did it in pieces. My suggestion to you would be to do the deviations and the squares at the same time. So in your calculator, if you just do 41 minus 41.5, enter, you get negative 0.5. If you leave that in your calculator right now and just hit the squared key and hit enter, it's going to tell you positive 0.25. Instead of having to retype in all your deviations to get the squares, just do it all at once. So go straight from your deviations, square them to get your squares. All of these numbers, this is important, should be positive. Positive. Because whenever you square something, you should get a positive number. If you're trying to square them separately, square something, like if you put in your calculator, if you type in negative 0.5 squared, it's going to give you a negative. Don't do that. Either hit the squared key after you get this, or you have to put it in parentheses to square it. Okay? Or square it and get the negative and just leave the negative off. Either way, all those numbers need to be positive. All right, so those are my squares. I add them all up. Okay, so think about it. We found our mu. We subtracted every x from my mu to get my deviations. We squared all the deviations. This is where we're at. Now we need sigma. We need to add up all of those deviations. So if you add up all those squares, you get 88.5. Then you have to divide it by n, and that gives you your variance of baby sigma squared. So we take 88.5, which is my sum of squares, and I divide it by however many numbers I have, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, divided by 10. So my variance is 8.85. Baby sigma squared is variance. I want normal baby sigma. I want my standard deviation. So I take the square root of 8.85 and I get 2.97. Pink. This is my standard deviation. Now, you probably think this is stupid and you don't know why we found this number. So let's talk about what it means. Standard deviation is actually super helpful in things. It tells you, so each individual deviation, so when we just did the x minus mu's here, we were finding out how far that number was from average. So your standard deviation is how far apart in general your numbers are, how spread out are your data points. So that standard deviation is 2.97, which means on average, you're only 2.97 away from that mean. That's really close together. 2.97 is a really small standard deviation because our range wasn't very big. If you remember for Corporation A, our range was only 10. You didn't start off very low, but you didn't end very high. Your range was super small, so the data points aren't very spread out. Okay, 2.97 is a small standard deviation. If we turned around into the other corporation that had a range of 35, my standard deviation would be a lot larger because those data points were more spread out. So I look at standard deviation like when I give tests and quizzes to see, like, the more spread out my data is, the less helpful, I guess, the average is. So if the class average is like a 70, which seems really low, but my standard deviation is super high, it's because somebody tanked it, right? Somebody probably got a 0, or maybe more than one person didn't take it and got a 0, and then that's pulling my average down a lot and making my standard deviation giant because they're all so spread out that it's really hard to tell what the actual middle is. So you're just to look at your standard deviation to see how spread out your data is. 2.97 is super close together. Our range wasn't very big. All of those data points were really close to each other, so your standard deviation is relatively small. Okay? It is helpful. It is used a lot. It's going to continue to come up, so don't just ignore it. We need to learn all these little symbols, and we need to know how to find it. 2.4a.